We are going to solve this equation, and the first thing we notice is that the logarithms have different bases. When logarithms have different bases, we cannot directly equate their arguments. To do so, we need both logarithms to have the same base, and for that, we will use a logarithmic property that allows us to change the base of one of them. We can choose to convert the logarithm with base 3 into a logarithm with base 9, or we can transform the logarithm with base 9 into a logarithm with base 3. Both options are valid and will lead to the same result. In this case, I will choose to convert the logarithm with base 9 into a logarithm with base 3. So, we leave the logarithm on the left as it is and apply the base change property to the logarithm on the right. The new base we are going to use will be base 3. This property tells us that we can express a logarithm with a different base as the quotient of two logarithms that already have the new base. In other words, the logarithm with base 9 can be rewritten as the quotient of two logarithms with base 3. The argument of the logarithm in the numerator will be the same as the original logarithm's argument, which in this case is the number 4. Meanwhile, the argument of the logarithm in the denominator will be the base of the original logarithm, which in this case is 9. Now, we are going to simplify the logarithm that appears in the denominator, which is the logarithm with base 3 of 9. Remember that a logarithm tells us the exponent to which we must raise the base to obtain the argument. In this case, we are looking for the exponent to which we must raise 3 to obtain 9. Since 3 raised to the power of 2 is 9, the logarithm with base 3 of 9 is equal to 2. This means that in the denominator, we have a number 2 that is dividing. To eliminate this division, we move it to the other side of the equation by applying the opposite operation, which is multiplication. As a result, we obtain a new equation where we now have number 2 multiplying the logarithm with base 3 of x on the left side, while on the right side, we keep the logarithm with base 3 of 4. Now, we will try to equalize the arguments of the logarithms. To achieve this, both logarithms must have the same base, which is already true since both are logarithms with base 3. However, the problem is the number 2 that appears on the left side of the equation, as it is multiplying the logarithm. To solve this, we apply the following logarithmic property, which tells us that when an expression is multiplying a logarithm, we can incorporate it into the logarithm by making it the exponent of the argument. In this case, it allows us to move the number 2 up as the exponent of x. We then arrive at the following equation. On the left side, we have the logarithm with base 3 of x squared, and on the right side, we have the logarithm with base 3 of 4. We have an equation that tells us that both logarithms are equal, and since they have the same base, the only way for two logarithms with the same base to be equal is for their arguments to also be the same. Therefore, we can equalize the arguments and obtain the equation x squared is equal to 4. We solve this equation by applying the square root to both sides to eliminate the exponent 2. This gives us that x is equal to plus minus 2. So the real roots of the number 4 are 2 and minus 2, which means that this quadratic equation has two solutions. However, although both are solutions to the quadratic equation, that does not necessarily mean that they are solutions to our logarithmic equation. For that, we will analyze each of these solutions. In our original logarithmic equation, x is the argument of the logarithm, so if we substitute x with 2, there is no problem. The problem arises when we substitute x with minus 2, since this would give us a negative argument, and we know that a logarithm with a negative argument has no solution in the real numbers. Therefore, x equal to minus 2 is not a valid solution for our logarithmic equation, which means that the only solution is x equal to 2. This is the end of this video. I hope you liked it and, most importantly, that you found it useful. If so, don't forget to leave a like and a comment. See you in the next video. Thank you.